our second panel, the Interop Future. Moderating this panel is Dani Osorio from Metaweb Ventures. Give it up for her, please.
Hello, welcome everyone to the Interop Future. I'm Dani from Metaweb Ventures, and I'd like to introduce our wonderful panel today. We have Jason Ma from Axelar, Alex Shevchenko from Aurora Labs, Mariano Sargenci from A16Z, and Alex Edelson from Secret Labs. Thank you everyone for joining us today. I would like to kick off today by having you introduce yourself and what you do that relates to interoperability. So, Alex, kick us off.
Thanks, Dani. My name is Alex Edelson. I'm CEO of Secret Labs, the developer of Secret Network. I joined quite recently. My past is in other blockchain projects like Layer 1, Privacy Coin, Old Beam, and a new kind of DEX. So I'm relatively new to this project. Now, in terms of what Secret Network is all about, it's all about confidential computing. So it is a blockchain where everything is done on chain, but the information is not visible to anyone. And in terms of Interop, we feel that privacy, confidentiality is a feature that is needed on every blockchain out there, and there are lots of apps that can be enhanced and even made possible when privacy is available. So a large part of our 2024 roadmap is about exporting our confidentiality features, and for that we're using interoperability, working with Axelar. We're also planning to work with Octopus to enable interoperability between us and the NEAR ecosystem, and we'll be looking into more ecosystems. So for me, Interop is key for the success of Secret Network and for actually delivering the much needed confidential computing everywhere it may be of use.
Wonderful, wonderful. Mariano.
Hey everyone, my name is Mariano Sargenci. I'm an investment partner at A16Z, and I focus on investing in infrastructure and DeFi projects. My background is as an engineer and engineering manager at Chia Blockchain, where I built a lot of the consensus, full node, and cryptography code base. And I've also focused heavily on light clients. And with regards to Interop, I really think the main three problems that we need to solve in the blockchain industry to take it to the next level are scalability, interop, and privacy. And we've already kind of solved scalability to a certain extent. We've invested heavily in privacy, and there's a lot of new solutions, but interop is still, I think, really early stage, and it's something we really need to focus on immediately to reach the true potential of blockchain. So I'm really excited about a lot of interop solutions that are being developed, and especially with things like L2s. I think interop is an interesting thing to invest in.
I'm Alex Shevchenko. I'm the CEO of Aurora Labs, the main developer of the Aurora protocol and different products that are inside of the NEAR and Aurora ecosystem. We are working on the forefront for the interoperability future for all of us. We launched Rainbow Bridge. This is the bridge fully trustless and permissionless bridging between Ethereum and NEAR. It has been in operation for more than 2.5 years by now. And the latest contribution into the interoperability from our side is Aurora Cloud. This is our stack for launching your own chains, similar to the L2 stacks. And the cool thing about it is that all of these networks that you are able to launch on top of the NEAR protocol are interoperable with each other, and they are able to cross-call each other.
Hey everyone, I'm Jason. I lead DeFi at Axelar. Axelar is a leading decentralized and full-stack interoperability solution. In addition to asset transfers, Axelar also has something known as message passing, which is the ability to pass any payload and call contracts across the 53 blockchains we currently support. Axelar has a rapidly growing ecosystem of over 100 projects building out, chain-agnostic applications ranging from, cross-chain swaps, cross-chain lending, asset management platforms, NFT bridging, and so on.
Fantastic. So there's a ton of momentum behind scaling solutions right now in the Web3 space. We think it's about to enter really like a Cambrian phase an explosion of optionality. You've seen everything ranging from L2s to rollups to L3s to advances in ZK technology. And this is exploding into a really fragmented and complex ecosystem. So my question to you is, how are all of these chains and layers connecting to Ethereum and other layer ones going to enable and preserve interoperability?
Well, I think there's various ways to do it. It depends on the system. So what we think of when we say interoperability is bridges, but there's more than just bridges. There's things like shared sequencers. For example, if you have multiple rollups or multiple L2s, they can communicate by sharing a sequencer. You have things like sharded systems like Near, where the interoperability is handled for you. You have things like IBC on Cosmos that also handles interoperability. And then there's atomic swaps, so swapping an asset on one chain for an asset on another chain immediately. And finally, there's bridges as well. And there's many different categories of bridges, which we can get into, but I think a combination of all of the solutions is necessary, and I really think that we need abstractions on top of all these things and all these blockchains, because a developer is not going to be able to reason about 100 different blockchains, integrate with each of them, know the security properties, the performance properties. What they want is one API, one SDK that handles everything for them, and they just assume that it has the performance and the security that they need.
Fantastic. And when we talk about this, when we talk about moving things in between chains, whether through bridges or shared sequencers or all these different alternatives, are we talking about moving assets, moving messages and data? What exactly do you think are the most important pieces that require, that need to be moved in order for interoperability to become a reality?
In my view, it must be generic, so it must include everything, starting with assets, but also functionality. So Secret is a great example. So we have this confidential computing where you can pass, say, encrypted data to a contract and perform some computations on that, and then get the results back without anyone seeing what went in the computation. And this is basically a functionality that requires general message passing. I think what Axelar is doing, and I think others will follow suit, we need really very easy to use and kind of transparent communication layer, because we cannot expect developers from one blockchain to understand the technology of all the other blockchains, or be a developer in multiple ecosystems. So those bridges need to work as best as possible and as seamless as possible to enable this, interwoven future where you get your functionality from different pieces and you just build this puzzle together for the best user experience.
That's a really good point, and both you and Mariano have now talked about bridges and sequencers. And why don't we go ahead and start defining what a bridge is? If Alex or Jason, you want to tell us through, talk us through that.
Yeah, I think we're still, in the early days of interoperability where we just call everything a bridge. And I think this is really like where we came from, right? And it hasn't been that long. I would say even like a year ago, what we started was, we had like 5, maybe 10 blockchains. And when people thought about interoperability, it was purely asset transfers, right? Where you would, lock an asset on the source chain, mint your app version of it. But from the user's point of view, they had moved one token to another chain. And that's what we associate everything with bridging. Message passing is a relatively new technology that came out in the last year. And most people don't truly understand what the implications of that is, right? Message passing, as I mentioned earlier, is the ability to pass any payload and call contracts throughout these chains. A very simple way to think about it is, rather than just moving an asset from one chain to another, now you can pass instructions. You can combine functions into one, and you can do things now like one-click cross-chain swaps or cross-chain staking, where you're combining multiple swaps with the bridging transaction, with the staking transaction, all into one. Why is that important? That's important because today, if you look at who's actually moving across chains and doing a lot of these very complex DeFi application, it's these power users, right? My parents will never be able to do that. For them to participate in DeFi and really drive adoption for the next billion people, we need to abstract away the complexities of that. And I think message passing, the ability to pass these kind of payloads across, is absolutely essential to achieving that.
Okay, and speaking about abstracting away complexities, would you say that the term bridge is actually a misnomer?
Yes, I would say so. I think like when I think of bridging as always just asset transfer, particularly involving a wrapped assets. I think as we mature as an industry, we need to separate between bridging and message passing. But ideally, we have a better way of even just denominating it so that
I don't
person
have
can
a
understand
better
it.
I thought about that a lot. Well, okay, so that takes us to a really interesting sort of segment, which is why do we need to bridge into all these things? Like, why can't we just use a base layer and operate? Like, what are the things? We talked about searching for privacy. We talked about searching for scalability. We talked about, you know, the modularity proliferation that's been happening in the ecosystem. So, what do you guys feel are some of like the really core reasons for why we need to be using additional layers on top of our technology today?
Well, from my point of view, the blockchain is all about the decentralization, right? So it is hard to imagine a single layer that is going to centralize all of the blockchain activity. It doesn't make any sense, right? So from that standpoint, the fact that there are many different L1 blockchains like Ethereum, Near, Bitcoin, it actually contributes into the robustness of the blockchain space. And because of this, we need to have also many different ways how we can bridge the gap in between these solutions, because blockchains, intrinsically, they are built as a thing in its own. It is a sandbox. Usually you don't have a way to go outside of the blockchain, and you need to have specialized solutions for this, like oracles or the before mentioned bridges and message passing. So we need to have this, to enable this interoperability, just because from the standpoint of the ordinary users, and I'm very with Jason here, that the internet itself, though it is a decentralized thing with lots of different servers running on different continents, is viewed by us as a monolithic structure, as an ordinary users, right? I can pop up the Amazon website, which is hosted on the US servers. I can then go to the Alibaba website that is hosted on the Chinese servers. And there is no difference for me as a user. It needs to be seamless. So the interoperability solutions are extremely crucial to make the decentralized world of the blockchain very convenient to use.
Awesome. And actually, Mariano, I imagine you're doing a lot of research on this specific category, and I was hoping you could maybe tell us a little bit about the categories and trade-offs between the different interoperability solutions.
Yes, so first of all, I would say within bridges, there's many different categories. I would classify them through their security properties. There's L2 to L1 bridges, which rely on the security of the L1, so they're much lower risk. There's like-kind bridges like Near's Rainbow Bridge, which also are really secure because they don't rely on a trusted party and a trusted group of parties to verify the bridge. And then there's finally the third category, which is a multi-sig bridge, or a bridge that relies on a small set of parties to transfer assets. So I would think that these different categories of bridges are applicable to different scenarios and different types of blockchains, and it would be great to get as secure as you can. If you can make an L2, that's the most secure way to bridge an asset. There's also different types of interoperability solutions like shared sequencers, which are only applicable to certain types of systems where these blockchains can basically merge together and work together. So these are not applicable for everything. And then there's message passing, which I kind of consider that in the bridging category as well. But it really depends on which type of systems you're dealing with. For example, IBC is only possible with Cosmos or Cosmos-like chains which integrate that protocol. It's not really possible with something like Ethereum at this point. So the type of interoperability solution is highly tied to the blockchain that you're bridging. And there is no one-size-fits-all, unfortunately.
So you talked a lot about sequencers, and right now it's my understanding that basically each L1 runs its own sequencer. Do you think there's a future where those might be shared sequencers between L2s?
It's possible, and it's especially possible if the things that you're sequencing are very similar. For example, if you're doing EVM L2s that all have the same EVM structure and all follow a certain protocol that is mandated by the shared sequencer protocol, then it's definitely possible to do a shared sequencer. You can, however, do something like share a sequencer between an Ethereum L2 and something like Solana because those systems are completely different. So there you would need a different kind of solution.
Okay, cool. And moving into like a spicier topic, we talked about security, so DeFi hacks, right? A lot of bridges involved in this. What's really happening and how can consumers sort of think about their bridge selection as paired with security models?
I can take that one. So, I feel very strongly when it comes to security bridges, right? It's obviously a topic that everyone always talks about. But I just want to say that it is not up to the average user to be cross-chain infrastructure experts and to be able to make the right choice so they don't lose all their money because something happened out of their control.
It's kind of crazy, right? That I have to make that choice. I don't know anything about how it's built inside, but it's the choice everyone has to make day to day.
Totally. I think as the industry grows, builders have to take more of responsibility to make sure they're using the most secure solution. And us as cross-chain infrastructure builders have to be better, to be more transparent and help educate the industry on what are the risks and what are the trade-offs. So, with that said, from an Axelar standpoint, we've always been really proud that we have committed ourselves to building a truly decentralized cross-chain infrastructure solution. Axelar uses proof-of-stake security because we're Cosmos chain ourselves, and we built it like that because we believe delegated proof-of-stake has been battle-tested, it's been around for a long time. And on our block explorer Axelar scan, you can see who exactly our validators are, the stake that they have, and their performance status, right? And it's because of these properties that when Uniswap Foundation did a very thorough cross-chain assessment where the technical committee actually went through the code of every solution, they realized that most of the bridges out there, I think they interviewed 6 or 8 bridges, only Axelar and Wormhole were decentralized and secure enough for cross-chain development. A lot of what we found with other industry providers is that, when you look under the hood, a lot of things isn't as described, and there were all kinds of security red flags. And I think, it was okay because even a year ago, the industry was moving so quick. People just needed something that worked, right? Whether it's bridging or asset transfers. And we, really sacrificed security for convenience, for speed. And we've seen where that got us. One implosion after the other.
Well, I mean, I think there's different philosophies on like how people design an architecture for a bridge and what they think they're prioritizing. Last year there was a lot of talk about an optimistic design. Since then the narrative has evolved. Maybe Alex, maybe you want to tell us really quickly, 30 seconds or so, what was your thought process behind the design and architecture of what you guys built for interoperability and bridging?
So we were looking for general message passing eventually. So we needed a way for an EVM contract to be able to call a contract on secret and vice versa. So it's not about bridge. We still have bridge, the classic bridge, the asset transfer bridges to and from, and it's very well developed inside Cosmos. But we were looking for true interoperability. By the way, I think in 5 years when we talk about those initial bridges, they will appear as antiques, very unwieldy and very simple machines just passing assets. And this is, to me, it's just a small part of interoperability. It's just passing value, right? We need to pass stuff. We need to pass to call contracts to do real interoperability as it exists in computing in other places. So we looked at the technology that was available, and we went through an integration process that was not very simple, but we succeeded, and it's working now, and we're quite happy. So we are also looking at expanding to other places. I mentioned with Octopus going to near by upgrading our IBC infrastructure. Preferably though, I'd love to work with a single provider because integrations are difficult, and developing this trust and building the feature set together is a good way to go, especially for specific use cases. Maybe we'll have two or three, but there should be one that is the most trusted, because again, the integrations are still not a very easy
complex
thing,
things.
right?
Absolutely.
Investing multiple times doesn't make much sense. It's much better to invest this energy into improving or fixing whatever is missing with the existing.
Yeah. great. Alex Shevchenko, do you want to tell us a little bit about your architecture and thought process?
Yeah, well, first of all, I would like to mention to everybody that security is a pretty complex topic, and it should be viewed as a multi-layered cake. Barriers for hackers and potential fraudsters not to exploit your system, right? And you obviously start with the proper architecture, and the architecture of the Rainbow Bridge is a pretty complex one. This is not like for average Joe even to understand it, not talking about the implementing it. But in short version, the light client of Ethereum is developed as a near smart contract. So you literally have a node of Ethereum on near that is working, and every 12 seconds that is synchronized to the Ethereum blockchain. And because of this node being inside of near, we are able to validate transactions that are happening on Ethereum. But there is also a near-like client operated as a smart contract on Ethereum, so Ethereum can do absolutely the same thing. And now these light clients are not very simple to build. But besides that, once you develop the architecture that seems as a proper one and it kind of addresses your security concerns, now you need to assess the implementation itself. There need to be rigorous internal procedures for testing, integration testing, reviews and stuff like that. And later on, you're going to a third-party security auditing company that must be also auditing this. And this thing is pretty expensive, especially if you would like to invite really professionals to take care of your solution. But this is not the end. Once you launch your solution, even if it is security audited, you need to install the proper maintenance and proper monitoring procedures around it to be able to act quickly, because in case there is an active attack that is happening, you most probably need to do something really, really fast. And I'm super proud about the Rainbow Bridge team, because the major attacks that were on the Rainbow Bridge, they were all automatically stopped within seconds by the automated systems that are monitoring the Rainbow Bridge state, right? And at the moment when humans were able to jump on a war room call and figure out what to do, I mean, everything was already done. We just needed to analyze the logs and understand what actually was happening, and that's it. But the final frontier, or the final two frontiers here, are the bug bounty programs. Sometimes there are bugs, right? This is like, we are all humans. AI is not yet at the stage when it is writing secure, permissionless and trustless generic bridges code, right? So we would need to get there. And there needs to be these bug bounties that are there. And Rainbow Bridge was paying out the second biggest bug bounty, and I'm extremely proud for this, because though it was a 6 million bug bounty for a hacker, this solution protected more than 500 million of user assets, and because of it being in place, these users are whole and in a proper way. And maybe in the future there will be some insurance companies that will be able to insure such things, but unfortunately it is a little bit too much at this point. So in case you're interested in any of these topics, they are actually presented on this conference. And for example, Mitchell from Immunify is going to be here. Dmitry Gudorin from Hacken. Immunify and Hacken are both the bug bounty platforms. They're giving their talks here too. So complicated things, not for average Joe, but any builder who understands that his smart contracts are going to be the home for large amount of assets or critical data, they need to understand all of these implications and need to make the proper measures.
Yeah, that's a very good point, which I think, when we talk about safety and architecture and design, that naturally takes us to standards. And Mariano, you mentioned you guys are investors in Layer Zero. There was an announcement a few weeks ago, and then a reaction on crypto Twitter from the community about cross-chain standards, so like ERC20. Do you want to talk a little bit about what was announced and what was proposed, and sort of maybe what are some of the implications or trade-offs about that?
Sure, yeah. So when you bridge assets or bridge messages between chains, let's say, for example, you want to bridge Ethereum to Solana, You can wrap your token in a wrapped bridge token. So for example, you can have a layer 0 wrapped ETH on Solana. You can have an Axelar wrapped ETH or a wormhole wrapped ETH. So you end up in a system where there's a lot of different competing tokens that don't necessarily interoperate with each other, right? There's not like one ETH token on Solana, there's different types. So that is not optimal. It creates problems with liquidity fragmentation, creates confusion for users, user experience, etc. So there are some talks of creating some standards where you have a kind of meta bridge, where like 5 or 6 bridges can be combined into one meta bridge. And any of those inner bridges can be used to create the same token on the destination chain. There's a standard called XERC20 or EIP 7281, which would do something like this, and they can set rate limits. So they can say, for example, each bridge has a max wrapped asset of $100 million or something like that. That could be really good for interoperability on the destination chain, but it does create risks. For example, you now need someone to manage that contract, to say which bridges are allowed, which bridges have which amount of limits. So there's a risk of hacks there. It's a completely new risk layer that you're adding. You also have problems with the least secure bridge being able to cause security issues for the rest of them. If one of those 5 bridges gets hacked, the whole meta bridge suffers and everyone else suffers. So if you're a user that wants to secure your assets with only the most secure bridge, you would be harmed with this meta bridge system. So I think standards are an interesting approach that we need to look into, but I'm not really convinced by them yet, and there's certainly trade-offs if you...
Yeah. Jason, you had some strong thoughts about that.
Yeah, I mean, I echo what Mariano said. I think it sounds great in theory. I know Axelar actually has recently had the support of Lido DAO to deploy staked ETH in Cosmos, and it was designed as a multi-bridge approach, where initially it launched just with Axelar, but we will then add wormhole and additional bridges later on. And as you know, we're looking at designing this and we're building this, we realize that there's all kinds of additional trade-offs, right? Having multiple bridges, as Mariano says, you then take on additional security risk of the other bridges as well. But then, bridges are very complex infrastructure, where you also have to think about things like relaying. So what happens when you send 2 messages and one of the relayers of a bridge fails? That could potentially disrupt the entire application and create a very confusing user experience, right? Not to mention there's additional trade-offs, like users then have to pay additional gas because you're now sending multiple messages. So I think the multi-bridge design is interesting, but it's still very much in its early days and comes with lots of trade-offs. So I think we'll see how this evolves.
DYOR, right? Okay, cool. So as we start to wrap up this panel, I did want to quickly touch on modularity and the broader trend that we're seeing about Ethereum as this global settlement layer and looking at the open web as a combination of different components and pieces, whether it's the application layer, identity, or data availability, or so on and so forth. So how do you see modularity playing out in this multi-chain future?
I think, right now I think we have more blockchains than applications running on them, like more L1s and L2s than the apps, which is kind of crazy. But I think at the end of the day, the networks that will stay active are the networks that have some specialization. Maybe speed, maybe they're good for a certain app, or maybe they have privacy built in, maybe something else. And in the end, this will be exactly the modularity that we're looking for, right? So an app will be running the main part of the app may be running on Polygon. It may store funds on Ethereum for more security. It may use Secret for some privacy feature. It may use something else for something else. And that will all play nicely for building, unbeatable and unstoppable applications and making the user experience great. So I see it that way. I don't think we need 10 versions of kind of exactly the same functionality. In the end, they will either merge or most will die out because it doesn't make sense.
Fantastic. Unstoppable applications. Mariano, 30 seconds.
Just to add here, from my point of view, modularity itself is an extremely great feature for all of us because it allows us to cooperate with each other instead of competing. So every single team will be able to focus on its smaller part and bring it to enhance all of the other team's efforts. So that's a great thing, and we need to figure out how to work through this.
Awesome. Any last thoughts? Modularity cooperation. You heard it here first. Thank you, everyone.
Thank you, Danny.